Hello, welcome to a new episode of TGI Kubernetes. After a little bit of a hiatus, I went on a big road trip with the family. Managed to avoid all the forest fires out west. Did not make it to a point where we could get drowned. Survived the summer pretty much. So before we get started too much, can everybody hear me? Does it sound fine? As always, every time we do this, I end up tweaking the setup a little bit, and I want to make sure I didn't screw things up. So if you can hear me, let me know. Okay, great. All right. Nice to meet you. A new hab. I'm sure I'm butchering your name, but nice to hear from you. And you're just a little further north. So we went to from here in Seattle, and we have a trailer that we tow, and we went to Glacier National Park, and then up into Banff, and then Jasper, and then spent a day in Revelstoke, and then all the way back home to Seattle. So it was a good old road trip. Did this wacky pipe coaster thing in Revelstoke that was a ton of fun. And then hiked to a tea house outside Lake Louise. So that was actually a blast. All right. So let's go ahead and get started. The plan today is I'm going to continue the controller, the sort of simple controller that I was writing last time. I got about an hour into it, did a lot of scaffolding, did a lot of explanation of what's going on. After thinking through it a little bit, we're going to take a little bit of a step back, and I'm going to go through a sort of easier way to start writing these things where you can start seeing some results as you go, and then essentially do a one-shot, sort of make something happen, and then wrap that thing into a controller. So that's what we're going to do today. But before I get started too much, let's see a little bit of notes of what's happening in the Kubernetes world. Let me go ahead and switch to the screen. So first of all, now this was Julia Evans, who has been learning Kubernetes and does these cool drawings, these zines. Do you call a single page a zine, or is it a book the zine? I don't know. It's like blog and blog post or blogs. I always bugs me when people have blog posts and they call them blogs, because the blog is the collection. But regardless, this cool hand-drawn diagram here of now she did this June 8th, and I must have missed it when it first came around, but I thought this is really awesome. And this summarizes some of the stuff that we had talked about sort of all the way back in the first TGIK. So about how everything coordinates through the API server, and then that talks to etcd. And so it's really great to see her pulling this stuff together. Very, very cool. Thanks for doing that, Julia. So that's kind of cool. Let's see, other stuff that's happening in the world is, and I don't have a tab open for it, but Amazon has this new thing called the Network Load Balancer that I'm really excited about, that they just announced. And this is a TCP-based load balancer that is sort of simpler and dumber than the traditional ELB or ALB, which is their newer one. So it's a new flavor of load balancer that operates at the TCP level. And that actually, I hope, and there's integration work to be done yet, but it's hopefully a new sort of simpler, cheaper option when you're actually working with AWS trying to get stuff into a Kubernetes cluster. So earlier today we had the AWS SIG meeting, and we did the AWS SIG meeting. Oh, and then Dan tweeted saying that he loves what we're doing here. Thank you, Dan. So earlier we had the AWS SIG meeting, and I think there's definitely folks who are interested in trying to figure out how to integrate this with the Kubernetes cloud provider for AWS. So and then look, there's Jeff's face on the page there. So that's really cool. So I'm excited about that new option here. And I think the cost structure for this, if I remember correctly, is based on number of connections, active connections, and bandwidth. And so I believe if you have one of these things set up and you're not actually, there is no per minute or per hour charge for actually having one of these running, which is really exciting, because I think for a lot of times, especially when you're doing development with ELBs, that sort of per hour cost tends to dominate. So that's actually something that's really exciting that I'm looking forward to playing with at some point. Haven't had a chance to really dig into that yet. Okay, and Anuba asking about what I think of Nginx Units. I haven't actually taken a close look yet. I know that the Nginx folks were really looking at getting involved into the microservices mesh game, and I assume. Is this a new code base application server built to meet the demands? I don't even know what it is. So I even look. I haven't even run all your applications under a common binary. Is this sort of like is this service mesh stuff? I know Nginx had made an acquisition and they were working at sort of integrating and retooling it, but I haven't actually had a chance to really dig in terms of, yeah. And so this is like a sidecar load balancer, and I know that they'd been talking about integrating it with Istio also. So yeah. And then Brandon says the Kubernetes on Mesos stuff. There aren't a lot of details on Kubernetes on Mesos yet either. I mean, all we really have is a blog post. My understanding, and hopefully I'm not speaking out of turn here, is that there was an article published in the Information. I think that was a little bit of a scoop. And so I think it rushed the timetable on the Kubernetes on Mesos stuff getting announced before. I know I was talking to another journalist. They were going to write about it, but they were embargoed. As soon as the Information did it, the embargo lifted, and this other journalist had to rush to be able to write his article and get it out there. So this is the way these things work, and so I think we'll probably be seeing a lot more details in terms of how exactly that works when the code is released, and I'm sure there's going to be talks and presentations coming out of MesosCon next week. I haven't, and so Paresh is one of the guys who did that, and we worked with him. I worked with him on the SIG cluster lifecycle stuff early on, so he's definitely been in the community for a while, and I know he was heavily involved in this stuff, or at least it looks like it. I haven't had a chance to talk to him about exactly what's going on there. Reading the tea leaves between sort of like what the blog post says and the stuff that's happening, some of the comments in Hacker News, I suspect it's something like Mesos is used to do sort of chunky allocations, and then Kubernetes, the Kubernetes scheduler, is used to do sort of fine-grained per pod allocations into those chunky allocations that are being done by Mesos. And so by doing something like that, it's not a fine-grained integration with the Mesos scheduling algorithm, but rather sort of using Mesos as a sort of coarse-grained sort of like placement and management engine across this stuff. So still trying to figure out exactly what that stuff is. So yeah, lots of exciting stuff going on. All right. Well, any other sort of topics du jour that folks wanna think about or talk about? Throw them my way. I forgot to grab a beer, so I'm drinking Diet Coke. I know, I'm kind of breaking my streak here. Okay, so let's go ahead and get started. I'll close some tabs up here. And I have a Kubernetes cluster up and running. And you can see kube control get nodes. I started this up about half an hour ago, getting ready to start here. And if I'm just going to remind people of what we were doing before, is that we were going to write a controller, and like a lot of things, just because we can doesn't mean we should. I'm not sure what I'm doing is a good idea. I think this is going to be useful. I was talking to a user and they had something that was similar. So what we're going to do is this is going to be a secret distribution controller. And so we're going to have a set of secrets of a certain type, or we could do this with an annotation if we wanted to, in one namespace. Probably an annotation might be the better way to do it now that I think about it. But anyways, and then we're going to have a way to essentially synchronize those and copy those into other namespaces. And so the scenario here is that I'm running a development cluster for a bunch of developers so that they have sort of a cluster that they can play with. And every developer maybe has their own sort of like playground namespace. And I want to provide secrets to them, but I want to do it in a way where we have a central sort of administration of these secrets, and I want those secrets to be updated across all of those different namespaces. So one way that we could do this is that we could, play a little sort of, set awk magic with a YAML file and do a kubectl apply to stuff so that I could actually do these things, but now, I'd have to continually run that thing as I synchronize it. The idea here for this controller is that I'm going to have one namespace, which essentially has my exemplar secrets, and then I'm going to take all the secrets from that namespace and I'm going to write them out into a set of other namespaces. So the idea being that this would be something that would be kind of fun and useful might be useful, but it's actually a relatively simple controller that shows how we can do this stuff. We're staying away from some of the issues around third-party resources and CRDs. There's a lot of good stuff going on there, but once you start mucking around with new types of resources, that imports a little bit of complexity that hopefully we can avoid a little bit here just by using some of the stock Kubernetes resources. Okay, so before what we did is we had a whole bunch of, make sure that file doesn't disappear. We had a whole bunch of scaffolding to actually get to the point where we could start writing the code. And so the first thing we have here is a main function, and this main function, oh, and by the way, the code that I'm starting with already is at github.com/jbeta/TGIK controller. So this is sort of the work in progress of where we left off last time. So if you guys want to play along with the home game, you can go ahead and do that. So yeah, a lot of scaffolding. So the first thing we do here is we bring this thing up. We're doing some stuff around version. This is just good hygiene. Anytime you're doing something that's going to be running as a server, having a way where it actually outputs its own version helps sort of present some insanity later. And then, okay, so Alejandro is saying that the Nginx Unit stuff is integrated with Istio and pointed at a GitHub repo that actually has some of the details there. So that's exciting. All right, so we're going ahead, we're figuring out which kube config we want to run, and there's a little thing here that says, well, if we don't have a kube config set, then I want to go through and I want to actually do this sort of in-cluster config thing. So this does a bunch of magic so that when I'm running this on a cluster, it uses the service account that's attached to that job. And then it creates the client, and the client ends up being the essentially our window, our object that we use to do stuff. And then we're creating a set of shared informers, or a shared informer factory that lets us create shared informers. It kind of scares me that we have things called factory in Go code. I mean, this kind of hurts my heart. But I understand what's going on here. I would have called that a shared informer creator maybe, just to avoid the word factory. But I don't think we have any factories yet. And so I have the shared informer factory, which this is something. So an informer is a thing where it talks to the Kubernetes API. It caches some subset of the objects that exist in the cluster. Objects being like RESTful objects, sort of API objects. So it caches those, and then watches for changes. And anytime it sees changes, it notifies some code. As it notifies that code then can actually get access to the caches. So it not only lets you write code that actually reacts in real time as things change in your cluster, but it also gives you a sort of cached view, at least consistently cached view of what's happening in terms of the notifications that you've seen so far, so that you're not totally beating up on the cluster all the time. In addition, once in a while, the informers have this option where they can go through and resync everything. So if you have a bug in your program and you sort of drop one of those notifications at some point, you can say, well, okay, just like, let's like replay everything just to make sure everybody's safe. And so that is what this parameter here is every 10 minutes, we're going to go ahead and do a resync. And then we're creating this controller thing. This is an object that I created. And then we start the informers. Oh, and then the shared part of shared informers is that with the Kubernetes controller manager, we have a whole bunch of controllers. They were each using their own informers, which meant that we actually had a whole like explosion of watches and caches. And with big clusters, that could actually create a ton of load and take up a ton of memory. And so the shared informer is a way to actually share this cache and this notification and these watches to the main API server across a bunch of controllers instead of having them be paired one-to-one. Okay, so Ruben is saying, do the new ELBs need to be warmed up? I don't think so. I think the PR and all the blog posts around this seem to hint that they don't need to be warmed up. I suspect, and this is my Google speaking here, is that some of the implementation or ideas are influenced or based on this project that Google wrote a paper called maglev about, which is essentially a sort of TCP sort of IP level load balancer written in software that's sort of software scalable and highly available. So there's a paper out there that you can read if you really want to geek out about this stuff, and that stuff ends up being a shared pool. So it's sort of true multi-tenant instead of having sort of an instance per customer. It's really, there is no sort of process per user type of thing there. I'm reading the tea leaves there. Who knows? Maybe at reInvent there'll be more details in terms of what's happening under the covers there. All right, so then we have the controller, and we're going to run the controller. And this is where we were. And so we have, when we create this thing, we're going to be listening to secrets and namespaces because those are the two objects that we want to be able to deal with. Okay, so Julia is asking, hey, Julia, how's it going? Shared informers, does that mean if you want to run several controllers that you wrote in a cluster, you should run them all in the same process? Yeah, that's a good idea. I mean, there's a trade-off here, right? If you all run them all in the same process, you can use these shared informers. That's great. If something crashes or makes it unstable, it takes down everything, and that could actually make things worse. Also, there's security concerns here. There is an option when you run the controller manager in Kubernetes and whether you want each controller to use its own service account, dedicated service account per controller. If that's the case, I believe you no longer get the benefits of the shared informers because you're actually segmenting from a permissions point of view what each of those controllers can see and do. And so there's a trade-off in terms of authentication, security, and shared informers. But a lot of this stuff really only comes into play with the largest clusters. I think, for a lot that most normal folks are running, the overhead of running multiple of these things, especially if you're running them in on your cluster so that they can float around, is going to be relatively minor. So, yeah, no, great question. Thank you. Okay, so this particular controller, and then Julia is asking, if each controller runs its own process, does that make sense to use a shared informer? So the shared informer is a Golang construct, so it's only something that's part of the client Go library, and so if you're running these things across multiple processes, there's no way to do a shared informer. So it's a sort of local cache for this stuff versus having to sort of beat up on the API server to get stuff going. Okay, and you don't need to use the shared informer if you're doing one process per, but you might as well write your code to use the shared informer, because if you do that, then it becomes more of a Lego brick type of thing where you can decide if you want to join these things together or not. So you might as well use the shared informer even if you're doing one controller per process, because it gives you some of that flexibility to plug these things together. Okay, so we have a secret informer and we have a namespace informer. because those are the two things that we want to react to. When a new secret is added, or when a secret is removed from, like, let's say that like one of the users says, oh, I don't want the secret, I want to delete it. Well, we want to actually put it back, right? Or if a new secret gets added to our template namespace, we want to be able to copy that stuff together, around. And then similarly, we want to react when a new namespace is added. So if a new namespace is added, like let's say we bring a new developer onto the team, we want to make sure that we start copying all the all the secrets into that. And then Andy says that there's other goodies that come with the shared informer. He's the expert here that you don't get with the regular non-shared informer. Okay, so basically the control flow here is there's a whole bunch of edge cases that if we were going to do this sort of in a sort of edge trigger type of thing, we want to be like, well, if somebody adds a secret to the template namespace, then we want to duplicate it to all the other namespaces. If somebody deletes a namespace, then or adds a new namespace, then we want to actually read all the stuff out of the template and then write it into that. So there's all these sort of edge cases that you could think about, saying like all these different events and cases that you want to do. And it's really, really, really hard to actually get all of those right and super error prone. So the common case here is just to say, nuke it from space. So, and what that means is I'm not going to worry about all those edge cases. What I'm going to do is I'm going to actually write a piece of code that says, take a look at the world as it exists, and let's make sure that it matches what I want it to do. So I'm going to actually go through and say, okay, show me all of the secrets that are in my template. Okay, show me all the namespaces that I want to talk to. Make sure that all the secrets that are in my template are the ones that are in those namespaces, and make sure that only the ones in those namespaces are the ones that I want, right? And if I do that, then that'll get all the edge cases, because I want to write code to make sure that things are perfectly synchronized. So the approach that we're going to take is we're going to write that code, and then we'll be able to run that in a sort of one-shot, one-off type of mode. And then we're going to take that sort of one shot and we're going to wrap that in a controller. And that controller is then going to say, if something changes, just run that synchronization code. So this is maybe a little bit less efficient than we could be if we wanted to make sure that we wanted to reduce load and we didn't want to look at stuff. But it turns out that the number of secrets and the number of namespaces are going to be enough that, like, if I just do a full synchronization every time something interesting happens, we're actually going to be in good shape. So does that make sense for folks? Let me know if that doesn't make sense. So I started going down the path before about actually making it be less, making it be more incremental here, but we're not gonna do that. So okay, but then I was thinking about okay, how do we make sure that caches are synced and all that stuff? And so we're gonna actually be a little bit more, we're going to try and simplify this a little bit here. Okay, so here's my run command for the controller. And you can see the first thing we're doing is we're waiting for the caches to be synced. And so this says that we want to wait for the client stuff to go ahead, talk to the API server, initiate a watch, and then get all of the or actually I think it does a list and then follows that with a watch. And make sure that we have sort of a cached view of what's going on. And in the meantime, that'll actually hit all of these functions here about sort of everything that's going on, right? And here we're going through, we're doing this on add, on update, and on delete. What I'm going to do here is that these things are going to essentially do nothing. I'm going to comment all of these out. Let's see. There we go. So I'm going to essentially sort of neuter those. So that means that we're going to be getting a bunch of notifications from the informer, but we're going to ignore those. Okay, and we'll bring those back in for a while. And then the next thing that we're going to do is, as I said, waiting for the stop signal here. Instead, what we're going to do is we're going to comment all this out. And we're going to do sync. I'm going to write a function called do sync. And that's going to be our thing that just sort of synchronizes all the everythings. Okay, and it's not parameterized at all. And so, oh, and Julia's asking all sorts of good questions. So read the comments. I'm not going to get into that because Andy's helping Julia out, and they're having their own cool real-time conversation there, which is awesome. Okay, so we have the on add, on update, on delete. And then we had this handle secret change before because we're going to see like, well, what happens if a secret changes? What happens if a namespace changes? I'm not going to worry about any of that stuff right now. And then we had this thing like I was going to do sort of an incremental thing, but let's do this do sync. So func C. All right, and I'm going to do logged up. All right. So this thing, so when I do the run, I'm going to wait for the cache to sync. We'll see a bunch of debug output as we get a bunch of those notifications, and then we're going to do a do sync here. And if I go ahead, and I hadn't actually done this, so let's like keep our fingers crossed. Oh, and then this temp.go, that's something where I have some code that I'm going to copy later in. I don't want. There we go. Okay, so go run star.go. All right, what did I do? Undefined copy secret to namespace. Oh, this was some vestigial code from before. Handle secret change. I'm going to actually turn this into do sync because that's what we're going to be doing. Undefined. Oh, I have to do C dot. Yeah. Okay. This is exactly what we expected to see. Okay, so Pat is saying, Andy, any pointers on the usage of the Kates.io API packager when we could start using the same? Is it too early at this time? I guess this is breaking out our API definitions into a separate package. Yeah, Andy'd be a good guy to ask about that. So there's this whole group inside of Kubernetes called API Machinery, and it's kind of like, it's the bowels, but actually in some ways the very core of how Kubernetes works, which is about how do we actually like handle all the API infrastructure and machinery. And so a bunch of the stuff that I'm talking about here is really in that API machinery stuff. And there's an ongoing project to actually essentially break this stuff out, make it more generic, make it more factored. And that's a core part of eventually how Kubernetes is going to handle its extensibility story. Okay, so here's what happened here is that I started the TGIK controller, and then I had that waiting for caches to sync. And so that's what you saw here, waiting for caches to sync. And then as the caches are syncing, what's happening behind the scenes is that the Go client, that shared informer, is going off and initiating those lists and watches and talking to the API server. And then as it actually finds out about a new things and adds it to the cache, it fires these on add events. And what these on add events don't mean that a new one was necessarily added to the API server. What it means is that in terms of the cache, in terms of your code's view of the world, a new one of these that you haven't been notified about before has been discovered, right? So these are like added to the cache, not necessarily added to Kubernetes. All right, so you're saying that. So Justin's asking, let's see. So Justin, what were you asking about here? That is this part of the, you're saying line 48 here? The add event handler. Yeah, you can, you can add multiple event handlers. I think you can, yeah. Because it says add. I assume that add means that you can do more than one. But we can go to definition. Is this going to work? Maybe. No, that's that. So that's a shared index inform. Okay, we're definitely in the add indexers, get indexers. Yeah, so you can add multiple there. All right. Okay, so this is great. So now we actually Now every secret across the whole system that we find, we are adding. Oh, so okay, so this is a problem that I had before, is that I start opening files and then VS Code starts like doing a whole bunch of Go stuff in the background. It spikes my CPU and then the video encoding starts getting jerky. Um, turns out that, like, no matter the amount of computing power we have, we can drive it into the ground. Okay, so we get all notified of all the secrets across all of the namespaces in the Kubernetes cluster, and what we see is there's a whole bunch in kube system. There's one in kube public, and then there's the default token for the default. And these are all for service accounts. So we don't have any non-service account secrets going on right there. And then once sort of those informers are like, okay, I've gotten everything, I'm caught up, then we actually go through, and that's when our code is going to execute. And so you want to wait until those informers catch up so that you make sure that if you're actually talking against that cache, you get a fairly complete view of the world versus a limited sort of like partial picture of the world. If you don't do stuff like this, you may find yourself operating against a very stale cache. And when you're operating against a very stale cache, you may say, oh, how many secrets do I have? None. Okay, let me go ahead and delete stuff. And so it's really easy to sort of like overcorrect and delete a bunch of stuff that you don't want to delete if you don't wait for these informers to catch up. Okay, so let's go ahead and we got to create our secret sync namespace. Oh, that's not what we want to do. So we're going to create that. So I'm going to do kube control create namespace secret sync, and then let's create a secret in there. Kube control create secret. Okay, so we'll do a generic secret, and I'm going to change this a little bit. Secret sync annotation. So if we have the secret sync annotation on there, then we're not going to be doing it as a type, because at some point the secrets that we might want to sync might be things like TLS secrets and stuff like that. So secrets have a type, and you can see that there's 3 built-in types, but you can create your own types. There's TLS secrets. These end up being used by the ingress system when you have it terminate TLS for you. There's generic secrets, which are just generic, and then there's like Docker registry secrets. And then when you create Docker registry secrets and then you attach them to a service account, that gets used when actually pulling your Docker image. And so those secrets are actually accessed outside of the pod when you're talking to a Docker registry. So originally when I was doing this, we're going to have a different type of secret, but I think what we want to do instead is actually use like a label or an annotation on this. I'm going to use an annotation. There's an argument on whether you'd want to use a label or an annotation, but let's just go ahead and use the annotation to start with. So I'm going to create a generic secret, and then I always forget the command line for creating a secret from literal. Okay, is my user super secret password. All right, so that's our secret there. Oh, name is required. We'll call it SSP for super secret password. Oh, key equals value. Oh, that's right. You have to do key equals literal user equals super secret password. Okay, so now if I do a kube control, oh, I did that in the wrong namespace. Darn it. We'll do namespace. It was secret sync. Okay, and then we'll do kube control delete secret P, and they'll delete it out of the default namespace. Now you kube control get secret sync secret SSP. There we go. Type is opaque. It should be generic. That's YAML. That's great. So here's the data, and you can see the key is user, and then this is a base64 encoded version of that password. This doesn't have our annotation on there. Kube control create I think it might have had there's the set of flags that you get when you're actually sort of using these imperative commands like kube control create end up being really spotty. And so instead what we're going to do here is we had a get, we're going to use this thing called edit. And so edit, let me move this onto screen for folks. Edit essentially goes, talks to the server, gets the YAML, lets you muck with it, and then posts it back to the server. And so we're going to edit the namespace here. And I am doing this from memory. Annotations. And the annotation that we were doing is called 80%.net secret sync. And we're going to set that to true. And then if I go ahead and close that. Oh, kube control annotate. Okay, so there's, yeah, so kube control annotate would have done something similar. Oh, unrecognized type string. So I screwed it up somehow. So let's use kube control annotate. What does that do? Okay, so we're going to annotate, oh well, secret sync, secret SSP, and then how do I want to annotate? I probably knew this at some point. Oh, and then you just pass these, they're not in flags, okay. So, and so then I do 80% equals true. Equals true. There we go. Okay. There we go. Okay, so annotations. I don't know what I did wrong before, but there you go. Okay, so now we actually have this annotation on here. So we have, this is the thing that we want to sync. So let's go through and let's write our do sync code. Okay, this is going to be the like do the stuff here. Oh, you thought I was annotating this the namespace, Andy? Yeah, no, I mean you could do it to annotate the namespace too, but that in that case we're annotating the secret. Okay. So the first thing we want to do here is we want to get all of the secrets that are in the, let's see, so what do we want to do? We want to go to that template namespace, and we want to get all of the secrets in that template namespace, and then we want to filter those to make sure that they have the annotation that we want to copy, because we don't want to copy, say, like the service account secret out, or there might be other random secrets that are in that secret sync type of thing. So we only want to do the stuff that actually have that secret sync annotation. And so let's first get those, and then we can print those secrets out, and that's something that we can run. So what we have here is we have this secret lister. Okay, so this is confusing because we have listers and getters. Getters, I believe, hit the live server, and my video is slowing down again. Does the audio cut out when I do this, when this happens? Let me know if the audio cuts out, because I think if my head stops moving, that's not a big deal, but if the audio cuts out, that kind of sucks. Okay, so there's secrets and listers, and Andy, correct me if I'm wrong, I believe getters hit the core API, so that'll actually pass the cache and hit the API server. And so that's what you're going to be using when you do an update, because like you actually want to update the live server. Or there are times when you want to make sure that you get the livest, freshest information versus actually using the cached information. And the lister then will actually use the cached information. And the APIs between these things are slightly different, which is kind of annoying. I think, it would be nice if there was like some sort of shared interface between these, and it was like a getter versus cached getter or something like that. But we'll work with what we got here. So we have this thing called secret lister, and let's go ahead and do that. So c.secret lister, what can I do with this thing? List. And I think that just returns, is there any options to that? I think that just returns everything, doesn't it? So, okay, well, okay, so this thing, so this takes a selector object, and then it returns an array of pointers to the secret objects along with an error. Okay, so we'll do secret. We'll do source secrets is what we're going to call this. And error equals this, and then this thing has a API machinery dot selector, and I don't know what that thing looks like. So I am not the expert here, so we're learning together on this stuff. And when it starts screwing stuff up, Andy's going to tell me what I'm doing wrong, because I think this is me embarrassing myself. Oh, this is label selectors. Okay, so, oh, that's too bad. So it's only labels that I can list there. So I want to do labels, but there's no way here to actually filter by namespace, is there, Andy? So I'm gonna get all of the. So this doesn't offer the same level of filtering that we get with the live client, where I can actually not only filter based on labels, but filter on some other stuff. So we'll just get it all. Now let's see, am I pulling in the right label? So this is one of the problems, is that we have a ton of packages, and a lot of the packages have similar names, and so it's really easy to accidentally import the wrong thing. So like, okay, so what I'm gonna do for secret secret lister dot secret. Oh, I can do that. Okay, so secret lister dot secrets. Oh, there we go. Okay, now I can do it in the namespace. And so I want to do this in my secret sync source namespace dot list dot labels everything. Okay, and then I'm going to go through and I'm going to just do a range source secrets. And then if error, we'll start out, we'll do log.panic. Oh noes. Okay. And then we're going to do log. Oh, well, let's do oh noes. And then do the error. So that way, or is there a log.error? I don't know. Okay. Log.printf. And then we'll do secret dot meta. This is object meta dot name. Okay. So let's see what we got going on here. So what this should do is actually print out all of the secrets. And that, oh, I don't want to annotate it again. Go run. This should print out all of the secrets from the cache. Oh, wait, 152. What did I do wrong? Did I have... It's my Go syntax has been so long. Like I've been on vacation for a freaking week. Now I don't remember anything anymore. Yeah, no, that was not my Go syntax. What am I doing wrong here? For range, expect comma, unexpected secret. We weren't expecting secret there. Isn't this like index and then the thing that I'm indexing over for source secrets? Source secrets is should be an array. All right, let's look at this again. So this is line 152. So I am looking, oh, here. I forgot a comma there. There we go. Secret sync type. Oh, which. Let's just comment this out. This is old code that's causing me problems. Yay! Okay, so yeah, so now what we see here is that we found these two secrets. We found the service account token secret, and then we found our super secret super secret, super secret. What was the SSP password? Super secret password, secret. And so we listed those out. So we got those. So that's great. And so the next thing we want to do is we want to filter through those. So then what we're going to do is, let's see. So we could go through. We could go through and do some sort of fancy sort of like mapping type of thing across these things, but that's kind of a pain. We could go through and how do you filter a list and go, what's the easiest way to do this? I think, you know what we're gonna do? We're gonna cheat. We're gonna cheat. This is really bad. We're gonna go do I there. I'm gonna do if secret dot let's see, we have object meta dot annotations dot now does the label package have some utilities for like mucking with annotations? Let's go ahead and look at that. So this is label selectors. I think oh, there's no annotation helpers here. Are there helpers around this stuff? Client Go APIs auto scaling. Why? Okay, so that's the auto annotations.go. Yeah, these are the type of thing where it's like it's a total pain in the butt because we get an array here and we want to actually say, is this thing in this array? And so you get stuck with like writing all these like gunky utilities to be able to search through this stuff. So this is just a standard set of annotations for auto scaling. Okay, so that's not what we want. There might be another package. And so I think over time, and I bet you, I guarantee you that someplace in the Kubernetes code base, oh, is it a map? Justin, you say it's a map, so I can just pull it out. Okay, but like there's utility someplace in the Kubernetes code base for doing all this stuff. Not all of that stuff has actually been pulled out into sort of really nice packages yet. Some of that stuff is in Client Go. So if we look in Client Go here, and let's see. And so Hans is asking, what's the difference between secret annotation, object meta annotations? I'm not sure. Let's look in a second. But like if you look here, there's like utilities. Well, there's package utilities, and then there's utilities because like, why do we need one package if not two? And so there's some interesting sort of stuff that's been pulled out. And I think there's a general effort, and this is actually kind of a help wanted place, is that ways to actually find some of these utility packages and break them out into their own independent thing. And that's something that we're going to be working on over time. Okay, so Andy's saying, okay, so this is a Golang thing here about this difference between secret annotations, secret object meta annotations. You can do this thing with Golang structs where you actually include a struct inside of another struct, but you don't give it a name. It's called an anonymous struct. And if you do that, you can access the fields of the anonymous struct directly without actually naming the interstitial sort of object, but you can also access it through the object. And so when I go through here and I do, oh, I don't want to break point, and I say secret.object meta.annotations, that's actually probably being more explicit than I need to be. So I can just go through and do this stuff, and that should work. Okay, so this is so we're saying here that with annotations, I can actually go through and maybe. See, is that a map? What is that? Is it a map of string to string? Oh, my computer's thinking hard. No definition found for secret. What did I do wrong here? So go to definition for source secrets. This thing here. Let's see, list. Oh, let's chase this stuff down a little bit. So list will actually return a v1 secret. Go to definition. And then this has type meta and object meta. So here's, you can see that it's being imported without a name, and so that's the anonymous thing. Go to definition of object meta. And yeah, and so, wait, that didn't work. Go to definition. V1 object meta. Is that going to show up? Or are we going to have to hunt that down? Maybe. This is generated code. Meta.go. Get object meta. Where's object meta defined? Where do we define that? That's got to be generated stuff. So maybe that's just an API in types.go. Sorry guys, this is useful stuff though to know how to. So whenever you're dealing with the API, you can go to, like, there's a website that has the API, but the reality is that most folks are, when they want to actually look up something about the API, they go directly to the types.go files that define the API. I would love to find time to actually write a really good sort of interactive site that actually talks about the API both from sort of RESTful level, but then also from the Go level and stuff like that, and provides a bunch of snippets of code to make this stuff easier. But you know, limits to the amount of time. So here you go. Yeah. So here's annotations, unstructured key value map. So there you go. So it's a string to string map, just like Justin was telling me, but I wanted to find it for myself. Like my kids. I do it myself. Okay, so if I have the secret sync annotation, okay. If that's not okay, then this isn't one of those. And then I'm going to go through and I'm going to do source secrets I equals nil. That should work. And then I'm going to do a continue, and then I should only print out, if I do this, the one thing that I had here, SSP. Yes, and I no longer printed the service account token. So now we've gone ahead and we filtered that. Is there an easy way to actually sort of like remove nils from a list? I'm gonna have to look that up. This is like those things where it's like, I'm an old fuddy-duddy and I don't program as much as I should anymore, and so I don't have all these tricks in my back pocket, and so I spend way too much time on Stack Overflow looking for like filtering a list. And let's do that. Like filter list Golang. This is how it works. Yeah, Stack Overflow. Okay. How does this person do it? Test. Okay, so this person just goes through and does it into a new array. So that's one way to do it. Oh, and then there's filter. Oh, Rob Pike's filter library. Is this old enough that, okay, this is from, so most idiomatic way. Again, it's a similar, so it's a similar type of thing. So you just create a new array and you do that. So like, why don't we go ahead and do that? So we'll call this raw secret, or we'll do this into raw secrets, and then we'll have, let's do filtered secrets, or let's do this one, source secrets. Var is a v1 dot, what is this? This is, the namespace is API core v1.secret. So source secrets, this is going from raw. So instead of setting this to nil, if this is actually there, then I'm going to do source secrets dot equals append source secrets secret. And we won't do a continue, and we'll do this, and then we'll do a log.printf print source secrets. What happens if I print that? Is it going to give me, I declare to not use, of course, because I'm not using it anymore, and I have to do, okay, yes, so we got that, and it went deep. It just didn't print the name of the thing. It printed the whole secret. Okay, cool. Okay, so now we got all of those. Let's go through and now let's list all the namespaces. What I'm gonna do, let's use the same annotation, but let's use that as a label on the namespaces for the namespaces that, or let's do an annotation on the namespace that we're going to target, right? Because we don't want to actually be necessarily putting this into every namespace. We'll just do it into some namespaces. So let's annotate. We're going to use the same annotation for here. We were annotating the secret in the namespace, but now let's annotate the namespace itself. So namespace, and we're going to do the default namespace. Okay, so now we have the set of secrets. Now we want the set of namespaces that we're going to actually targeting. So I'm going to do we're going to do raw namespaces, c.namespace lister dot well, this one dot list and labels dot everything. So generally you index on labels. So like if I did this as a label instead of an annotation, I wouldn't have to write this loop to do this stuff. We'll go through and we'll figure out error handling later. Var target namespaces pi core v1 dot namespace. So no. And then we're going to do the similar type of thing here. So raw namespaces. If namespace dot annotation dot secret then I'm going to target namespaces. And then for range target namespaces log up print ns dot name. Oh, undo go run. There we go. All right, so yes, so here is, we got the default namespace because that's the one that we annotated. So we're good to go. So those are all our target namespaces. And so now what we're going to do is we're going to, let's go through and, so we have this function here that I started writing, which is copy secret to namespace. What do we want to do here? So we're going to have a function. I'm going to create a function here called c.sync namespace. And we're going to pass in our source secrets. And then we're going to pass in a namespace. And we're going to do that for loop for, well, I guess we don't have to actually create the target namespaces. Well, let's just do that because it's so for range target, because we could just do this inline, but I think it's cleaner if we, okay. So we're going through and we're syncing namespaces. We're going to copy this. We're going to rename this sync namespace. And we're going to have secrets is going to be an array of those. And then the namespace is going to be the API core v1.namespace that we're going to. Probably don't need the full namespace. Let's do namespace.name, and then we'll just actually make this be a string. Okay. And so let's put together a plan of what we're going to do for this function. To do, we're going to create, update all of the secrets in this namespace, and then we're going to delete secrets that have annotation but don't have, but are not in our source list, right? Because if I delete a secret, I want to go ahead and delete this here. And that should be the plan. So let's do the first thing here, which is create, update all the secrets in the namespace. And so for each secret in range secrets, I want to go through and I want to actually go ahead and let's do something dumb. So that ideally what I would be doing here is I would be checking to see if that secret looks the same in the cache as the one that I have. And I would be doing a sort of a deep compare there. But that's going to be a little bit of code. So why don't we just go ahead and do like a create or update type of thing here, and see how that works. It's going to be a little bit of pounding on the API server. Okay, so we're over time here. Actually, I just noticed it's 2 o'clock. I'm going to keep going. I mean, you guys can drop, but like I'm tired of talking about this stuff, so I just want to write the code. An hour is really not enough time to really get into stuff. So hopefully you all can still tune in. I don't know how many of you are watching. Okay, there's still folks watching. So I'll probably go for like another half an hour here, and maybe we'll pick this again up next week, or maybe I'll do an extra bonus time when I have time, and we'll actually just finish going through this stuff. But okay, so what I'm going to be doing here is that for each of these secrets, I'm going to go through and just clobber this in. And so I'm going to go through and create a copy of the secret. And now I believe that Kubernetes has a bunch of generated code for doing deep copies of objects. And so if I do new secret equals, let's see, deep equal generated deep copy. So what is the naming pattern here for this stuff? Oh man, this is some nasty stuff. Okay, what do we got going on here? Deep copy. Okay, so we have deep copy API secret. It's just in, out, and takes a conversion cloner. I'm deep into the guts of some of the voodoo here. Let's see. Is it just used here? And then there's a whole bunch of these. So now, okay, but I need a conversion cloner. What happens if I don't have a conversion cloner? Because it's a pointer. So this goes to, okay, so things get very meta here. So this is c.deep copy, so that'll crash if I don't have one of those. What is a conversion cloner? So, okay, go scheme, and okay, you need to use the client go scheme, and then you can do scheme deep copy. So this uses a bunch of reflection, Andy, to be able to do this stuff. I don't have to actually call into the generated code directly. I think that's what you're saying. So let's try that. Scheme. What would I do without you, Andy? Deep copy of secret, and that'll probably return. We'll do either if, okay, we'll generate users. Now, did I get the right package here? Client Go Kubernetes scheme. Yes, so I got the right one. Cube 1.0, you can just do secret.deep copy. That's going to be great. Okay, and then Hans says I could probably do a JSON Marshall on a Marshall. I think, yeah, that might work also, but Andy says deep copy is more efficient. So this sounds good that I'm doing a deep copy here, and then I can do something like, what I kind of want to do is I want to do like new secret dot namespace equals ns, right? But okay, so the first thing that this isn't going to work because this thing is actually going to return a this is going to return an interface, so I have to type assert it. Yeah, Andy's telling me there. So I need to go through, and this is going to be a star API core. Is it v1.secret? Maybe that'll work. Okay, and then I want to go through and I want to actually do that, and then let's do just a check here to see if this compiles and if I screwed stuff up. Now there's other problems I'm going to hit here. Multi-value scheme, deep copy, and single value context. Oh, does it return an error too? Because what could go wrong? I believe in this case nothing could go wrong, so I'm going to ignore the error. Multi-value, okay. Oh, okay, so new secret. Okay, this is a pain. This is a pain. It returns an object and the error, so that means I have to actually create a temporary I have to create a temporary one, and then I have to do new secret API core v1.secret. Okay, I think that gets me there. Okay. So here I go through, and this isn't super readable. I could do like, there's like some cool pretty print utility. Okay, I'm not gonna like find that package right now. This is total yak shaving. Okay, but I can go ahead and do this, and let's try and like look at this. So the name of this thing, I got the namespace was updated to default, so that looks good. We have things like the self link here, which is still wrong. We have the UID. It's going to be a different UID. There's a whole bunch of other stuff that actually goes on here, generation and stuff like that. I think most of this stuff, if you try and set this, Kubernetes is like, you're not allowed to set that. That's no good. I don't really care. The one thing that we want to be careful of here probably is, so type is the resource version. And so the resource version is used when you're doing an update to make sure that you don't get two people trying to update and clobber each other. And so there's sort of optimistic concurrency. So if you post something with a resource version and you're updating something that has a different resource version than the one that you're doing, you're essentially saying this is the base of the version that I'm updating. And because we're actually doing this to actually create a new one, we don't want to go through and use that resource version, because we'll probably get an error back. Okay, Bernard is like, do you have any good links or references that explains all of these auto-generated functions? No, this is one of the weaknesses. We don't have a lot of great documentation in terms of all the cool auto-generated stuff that we do. There's a lot of auto-generated stuff. It actually makes some of this stuff really nice and efficient. But you kind of have to be an expert with this stuff. And Andy had to go, so I am now flying blind without Andy. He's on the East Coast. It's 5 o'clock on a Friday his time. So so what that means is I'm not going to have his help. I'm going to have to actually find a way to go through this myself. Okay. So here we go through, and we're going to do this, and then we're going to go through, and we're going to do new secret dot, and then we have well, let's do it without doing that and actually see what happens. And now I'm going to actually go through and do c dot namespace getter. It's called a getter, but like namespace, no, not namespace, secret getter. Secrets dot, maybe. Am I doing something? Is it still thinking? Okay, I think this is the thing that I used to update. This is the client. secrets getter. So that's a core v1 secrets getter. Client.core v1 as a secrets getter. Okay, so secrets getter is an interface. And if we go to the definition of that, okay, so secrets, we have to do the namespace, and then here's where I can actually do all the updates and stuff like that. Okay, so secrets, this is for namespace dot, let's try and do a create. There is no sort of create or update type of thing. And then I think here I pass in a pointer to the secret, so new secret, and that's going to return the secret along with the error. Okay, so let's ignore the return because I don't care. And what we're going to do is we're going to print the error. So let's see. Let's run this. This should go ahead and create it. Maybe it may actually, let's see, does it puke? Resource version should not be set on objects to be created. So that's what we expected to happen, right? New secret dot resource version equals, is this a int? Let's do 0. What does that do? Oh, type int string. Okay, so this is. So we'll do that. Awesome. Okay, so we didn't have an error, so that's why I printed nil there. But now, okay, so now if I do cube control get secrets, this is in the default namespace. Here I have SSP, so this thing actually got created 10 seconds ago. Sweet. And I'm going to do get secrets secrets ssp.o YAML, and this doesn't look totally nuts. And I believe if we look, the UUID here, CB6E, is, oh wait, is there something different? B808, sometimes the UUIDs are, did it actually copy the UUID? So let's see, did we, okay, so this is kind of bad because we probably, I'm actually surprised that Kubernetes lets you, oh no, it didn't. Okay, so the front here, so it actually ended up creating a new UUID for this. Okay, I wanted to make sure we weren't like confusing stuff. I'd be surprised if it let you do that. And so a bunch of the stuff that only the server should set, like the creation timestamp and stuff like that, that stuff gets updated, and when you do a create, it doesn't actually let you update that stuff. So now if I run this again, let's see what happens. We're going to get an error this time. Secrets SSP already exists. So that's kind of what we expected to happen here. So let's actually take this error. So like we're going to do this. We're going to do if error dot. Okay, so there is, I'm trying to remember where I've seen this before. Let me look at, so I'm going to copy code from kubernetes.kubernetes. Let's see, controller. I think I did this with the Bootstrap stuff when I wrote this. Bootstrap signer. Okay, so there's this cool package, if API error dot, is this going to work? So there's is conflict, or if we look at, we'll use the, go to definition. So there's this API error package that helps you deal with these things. Oh, file, like something's going wrong. Okay. No, that's not what I want. That's enough. Did I get API error up here? No, I didn't get the package. Where is that package? Machinery package, API errors.go. Okay, so I think this is it. status debug error. There's all sorts of is conflict. Okay, so here's, okay, so I have is not found, is already exists. That's what we want. Okay, so if I do API error dot is already exists error, then I want to go through this getter dot secret dot update new secret. Okay. And then let's see, if error does not equal nil, go ahead and we'll output it there. All right, so, oh, API error, so undefined, so we don't have that package. What is the, oh, it's called, okay, so this is again, yeah, so we have errors, but there's like a gazillion packages called errors. And so this thing is in kates.io API machinery package API errors. So like, can I copy? That'd be useful if I could actually copy that text for the path. No. Copy path, oh, look at that. Yay. All right, so now we're going to create a thing called API errors. And this has a whole bunch of stuff, but I only need this. And I don't need errors.go. Oh, that's not, if I save it, it gets rid of it. API errors. Did that work? Yeah, there it goes. Okay. Error declared and not used on line 189. Oh, because I'm doing this. Okay. Okay, so operation cannot be fulfilled. Invalid object. Precondition failed. UID and precondition, blah, blah, UID. Okay, so now here's the problem again, is that I'm in Kubernetes, I'm trying to update an object, but the object that I'm updating, the source that I'm updating actually has the UID of the source secret, and I'm trying to update the UID of the target secret. So let's go ahead and let's clear out the UID also. UID equals, let's do that, and now let's see what happens when I run this thing. Boom. Okay, so we updated it. And so what this means is that if I go through and let's test this out a little bit. So let's go through and get what do we want to do? So let's go through and create secret. So here I created the secret with super secret password. Let's do foo equals bar and YAML dot so dry. So I'm just, because of the basics, so I want to actually add this here. So this is foo equals bar. I'm going to do an edit of my super secret thing. I'm going to add a new value to that. Okay, we're going to go through and we're going to do that. So now I'm editing this thing. Okay, and now if I do a kube control get secret SSP here, I have just user, but if I do it in namespace secret sync, I have user and foo equals bar. Okay, so I made a change to one of the secrets. Let's see if we can actually propagate that through. Let's do a go run. It did the sync. Now I'm going to actually get the secret again, and now we actually have foo equals bar. Okay, so we're doing a creator update here. We're a little bit inefficient because we're updating even when things are the same. So we're doing a bunch of no-op updates, which means that if we're doing this with a high churn rate across a whole bunch of namespaces, this could get really expensive and create a lot of load on our API server. But it works. It ends up being a no-op. Okay, so that is one of our to-do item here. So number 2 is to delete the secrets that have the annotation but are not in our source list. So let's go through and let's name. So we got to do a little set math here, right? So we want to get all the secrets that are in our target. We got to get all the secrets that are actually in the namespace, and then we have to delete those secrets that are in the namespace but not in our source, right? So let's go through. How are we going to do this? What you'll notice here is that if I'm, where did I find it? So there's some, again, one of these like fun utilities is that there's, not in Docker. Why did I, okay, so like I'm vendoring in Docker because like in the Kubernetes world, vendor all the everythings. So I believe I just saw this, that there's actually utility. Maybe it's not in client Go, it's in, here we go, sets. Okay, so this is in the API machinery package that we're vendoring in. And this again is an example of something that's really useful that we haven't done a good job of breaking out. And we have a string set here. So this is actually really, really good. And so this is auto-generated with this util called setgen. So you could do this yourself. But we have this thing and it's in a package called sets, and we have the string sets dot, let's see, string, how do you use this thing? This file is auto-generated. What do we do? So we can do difference, we can do intersection, is superset equal, length less, sortable, list. How do I create one of these? It's just a sets.string, I think. Ends up being the type. Okay, so let's go through and let's see, so. And then we're going to do this. We're going to have source secrets. That name hasn't been used yet, equals sets.string. We're going to have dest secrets target. And then let's see, did I pull in the right sets? Yep, there we go, pulled in the right package. This is one of the things as you're writing code for Kubernetes, you'll notice a lot of times that you accidentally pull in the wrong package, so you kind of get in this habit of checking. So I'm going to do for secret in the range of secrets. I want to go through and I want to do source secrets dot insert, and I'm just going to do this based on the secret name. Yes, secret name. Okay, and so I'm going to do secret dot name. Okay, so there's all of those, and then I want to go through and I want to actually list all of the secrets that have the annotation in this namespace. And so I'm going to actually create a helper function here. I'm going to do func, and this is going to be get secrets in namespace. And this is going to return, a list of probably want to return an error there, but we'll see if we need this. Secrets for secret in, oh, and then we need to actually get the thing too. So raw secrets, we're going to do a secret listing, and then we're going to use the namespace that we passed in. We're going to list everything. If error not equal nil, we're going to return nil error. That work? Yeah. Yeah. Let's see, give me a second here. All right, so there we go. And then, where was I? Get secrets and namespace. Okay, so we're going to go ahead and do that. We'll return that. And then we're going to get the secrets. We're going to go over those. We're going to check for the annotation. We're going to append that to secrets. And then we're going to return secrets nil. Oh, what is... I got an error someplace. And then this thing here, I'm going to do source secrets there equals c dot get secrets and namespace, and then the namespace is secret source namespace. I'm going to do my own nose, and then I should be refactored that thing out. Oh, do I need parentheses around this? Okay. All right, so now I can do target secret list error equals c dot get secrets and namespace. The namespace that I'm working with is the one that was passed in. If error does not equal nil, we'll go ahead and we'll print that out. I want to go through, and then I want to go through and I want to, let's copy this code here. Secret target secret list, and then target secrets. All right. Let's see if this actually runs. Secrets used as a value. Secrets. Oh, range. All right. Panic assignment to entry in nil map. Oh, so let's see. So when I define this, I want to do, these things need to be initialized apparently. So let's do that. Okay, caches are synced here. We didn't print anything, but we didn't get any errors. And so now we want to do, if we look at this thing, we want to do has all different. So we want to go through and look at the difference. So S1 difference S2. So we want to take the destination minus the source. So we want to go delete set equals, is this how it works? The target secrets dot difference source secrets. And then how do we do an iteration? So we can do unsorted list. Okay. So we can do for actually we can just do, I think these things just store true, so we can do secret name nil or range change delete set. I'm going to do log.printf delete secret name. Let's see how that works. Oh. All right, so we don't see anything there. But now if we go through and let's set the annotation on the secret sync, we're setting this annotation. So what we'll do is we'll clear the annotation off of this thing. So now we'll no longer want to sync this thing. Oh, did that not work? Annotate. So how does annotate work? Oh, you have to put so the way you clear an annotation with this command is you put a minus at the end like that. So that'll actually clear the annotation. Now if I run my code, it should say that it wants to delete that secret. Yes. But we're not deleting it yet. We're just marking that we want to delete it. So now we can actually go through and actually delete it. And we do c.secret_getter.secrets for our namespace delete. And we're going to pass in secret name. And then there are delete options. So let's see what the delete options are. Hopefully you all are still sticking with me here. I'm having fun, but I know this is kind of in the depths of it here. Okay, grace periods, preconditions. So this is the thing. It's like, oh, I only want to delete if it's if the particular UID matches up, stuff like that. So we are not going to do any of these things. We're just going to go through and really just delete stuff. There's all this stuff around propagation. So if you delete stuff, there's this idea of sort of child objects. Do you want to go ahead and find those, that type of thing. So I think, let's see if we can pass nil in there. And then this will return an error. And then we can let's just log it for now. And it deleted it. So get, and it says, oh, I don't have that secret anymore. So we actually did a synchronize. And now let's annotate. Let's add the annotation back. And we'll run our program. And it created it. So we have to do some more logging. So now essentially what we have here is we have, and I think this is probably a good stopping place, is that this do sync function here is actually written. And what this does is it lets, and it's probably worthwhile to like have some better logging and error handling and stuff, but it goes through and it lists all of the secrets in our exemplar namespace. It lists all the other namespaces. It filters both of those based on an annotation. And then for each of the target namespaces, it goes through and makes sure that with the set of annotations, that the set of secrets in the target namespace match the set of secrets in the source namespace. And so this is the basics of the synchronization that we want to do. So the next step is to take this function and then run this function every time we notice a change with the controller. And at that point, we're pretty much done, right? Because now, essentially, you anytime you actually have, thanks, Pat. Anytime you actually, so you have this thing, you have the thing that you want to do, you know how to do it with a one-shot type of thing. And now we can actually go through and automate that and actually make it real time with the controller pattern. And so I'm pretty sure that I at least can get to a good sort of like functional controller next time. So we'll go ahead and we'll do that next time. But I'm going to check in this code that I have right now and go ahead and update that so y'all can take a look at that. And with that, any last questions before I go ahead and sign off here And I know this one ran a little long and we were really deep into the code. I'm having fun doing this stuff. But hopefully this is useful for folks. Any last questions? No? Nothing? Waiting for the delay here. So YouTube has a mode now that is like super low delay. But when you do that, you don't get the DVR utility. So you can't sort of rewind while you're actually doing the live broadcast. And I haven't chose that yet because I really do think that it's useful. Like if you missed something, or if you're like, hey, that's interesting, being able to rewind. So for now, unless folks tell me otherwise, I'm going to keep it with the sort of medium delay where you get the DVR stuff. Let's see. So Bernard is like, is the UID the canonical way to identify an object? Yeah, the UID is unique in space and time and across clusters probably. And so if you delete an object and then you recreate it, it'll actually come back with a different UID. So that's a really useful thing to know about. Depending on sort of what you're doing, whether you care about sort of like tracking whether it goes through that delete create transition or not, the UID ends up being the right way to do it. What I would not do is look at something like the resource version and the name and use that resource version with a name without the UID in there, because there's no guarantees. I mean, generally the resource version is monotonically increasing across a cluster because it's based on an etcd counter. But I don't know if there's any sort of real guarantees around that. All right. Well, thank you guys. Next week we will finish off the controller, and hopefully that'll actually be useful, and that's going to be a template that we can use for doing other stuff. I think maybe I might have Andy do this because he's kind of the expert, but he's been working on some stuff about like how do we actually do stuff with CRD. So maybe an interesting thing for us to do in the future would be to turn our exemplar secrets from being sort of a secret themselves into being a CRD, and use that as an example here. So that might actually be another sort of next step to take it. All right, I'm Vikram from India. Hopefully all the packets are making it all the way across there and you can see this stuff. So I'll be posting this, and have any questions, go ahead and leave them in the comments on the YouTube page after the video's up, and I'll definitely make sure I read those before we go ahead and start next week. Thank you everybody for tuning in. I really, really appreciate it, and I will see you next week.